Hi, I am Dr. M. Kamakshaya, open source software evangelist and also a full stack web developer. Developing full stack applications, especially for healthcare domain, is my passion. I often do this as a matter of my teaching activity, and also I provide consultancy services to a couple of software firms and also a couple of other hospitals. So this video cast is all about talking about a particular software application which I developed just recently, known as patient satisfaction auditing systems or patient satisfaction audit systems. This application is very much important for those hospitals which would like to do auditing of patient satisfaction as a matter of healthcare quality. Patient satisfaction and expectations is one of the important measures as a part of healthcare quality. For that matter, hospitals try to evaluate the service quality, and patient expectations is one of the important measures or metrics that need to be calculated while ensuring healthcare service quality. There is a lot of documentation, and there are so many models, theories, but I'm not going to talk about all these theories and models in this video cast, because the primary purpose of this video is only to introduce my software application. I created a small software application based on my research on impact of service quality, healthcare service quality over patient behavior. And this particular technology, software application which I am talking, actually belongs to a non-clinical area. So I'm not just trying to advocate to clinicians. It doesn't fall in the area of clinical analytics. It just fall under non-clinical analytics. Now I have this uploaded somewhere in my GitHub repository with a different name. Actually, this is RGFSim. This is actually the software available from my GitHub repository. You just have to go to github.com/kamakshaya, and there when you click on RGFSim, you can just clone or download this zip. And once you download the zip, this will be something like this in your, you see here, RGFSim kind of. So inside this folder you have this file, and when you right click, you will find, by the way, I developed this application by using RStudio, RStudio. It is platform independent. It can be opened in any operating system as far as RStudio is installed properly. Now you see this file is associated with RStudio, and when you click this, that will be opened inside RStudio. RStudio is a editor meant for writing our programs. R is a language very popular in data science and analytics, and this patient satisfaction is in fact one of the web applications that falls in the area of non-clinical analytics. And since R is meant for data science and analytics, so I used R infrastructure to develop this application. Actually, I implemented a particular data analytics technique called structural equation modeling in this. So I used a couple of packages. Here you will find PsychSim, MAS, and all. These are some of the prerequisites. By the way, to open this application, you cannot install this because I am not supplying this application as an executable file, and that is available through consultancy. I can only provide executable files or binaries through consultancy. This is just a free software application, so anybody can just obtain this file and open, but you need to open this like a programmer. You need to have RStudio, and you should open that file inside the RStudio, and then you just have to run app button. So now this application will be opened in the web browser. It is actually RStudio default web browser, and you can also open in your default web browser of the operating system. For that, you have to press this button, open in browser, something like that. Anyway, I will be continuing in this. So the very first menu is the dataset. You see here the PatSatAudSys. That is the name of the application, Patient Satisfaction Audit Systems. This application might be very much useful for those hospitals who would like to ensure who wanted to monitor the patient satisfaction. By the way, there's a lot of theory that patient satisfaction is one of the important prerequisites to ensure healthcare service quality. And I'm not talking about the theory and the models. There's a lot of information online. This is only this videocast is only to introduce this software application for those hospitals who are interested in doing patient satisfaction auditing. Okay, there's a lot of norms and regulations as why patient satisfaction or expectations need to be monitored by the hospitals, and the hospitals also need to provide this as one of the important metrics on their websites, kind of thing. This is just a backend application. So anybody in the hospitals can just acquire this application, open this, and start doing the analysis. Now there are different menus here. The first menu is the datasets. You'll see here you can just browse for the datasets. By the way, there is a consistent methodology as how to measure the patient satisfaction. I assume that this application can be used for different types of datasets. I'm going to explain a particular scenario where the patient satisfaction is measured by using an approach called ServQual, and this service quality or ServQual service performance, service quality is one of the sort of techniques in service management. Since hospitals falls under the service sector, so hospitals need to. I'm explaining a scenario where my dataset, which I'm using for this particular activity, is collected. The data is collected by using a particular approach called service quality, and in that I'm going to show you the data set. So when you open the data set, you see here this is actually the 10 criteria approach of the service quality. So as per the theory of the service quality, there are some important components or factors. You see here, these are the 3 components that belongs to communication. Here these 3 components, these 3 variables belongs to responsibility, and this relationship, tangibility, empathy, something like this. So this is the theory actually. So you just have to imagine that let us assume that I collected this data by using 10 different factors of service quality, and I have that data measured by using Likert scale. You see here, these are all the responses of the Likert scale. These responses are measured by using 5-point Likert scale, or 5 items Likert scale. 1 stands for poor, very poor, and 5 stands for very strong, something. Opposite of the scales, 2 extremes of the scale, something like that. Now there is a menu for statistical analysis. You can just go to this summary statistics, and then here you can just, suppose if I wanted to create summary statistics for very first variable of the factor communication. Here you see there are, but anyway, summary statistics is not meant for this. This is ordinal data. We cannot just do this. Most of these statistics are not meant for this. This is actually the frequency table for 2 different variables, and then you have the plots. In plots you have the histogram. You need to choose one of the. Anyway, histogram is again not meant for ordinal data. You see here the data is 1 to 5. This is not continuous data. I am talking about research methods. I don't know how many of you are. In case if you are not able to follow my talk, you can just write to me to my email ID, which is there on GitHub as well as on YouTube channel. I can provide you training, and then we can go for bar plots, maybe kind main communication. maybe scatter plots. You see this is pie chart is not in a way, yeah, of course this is a basic pie chart. I don't like to, and I would like to provide the advanced methods through consultation. And then you have tests. You can test normality. This is univariate normality. Suppose if somebody asks the question like, is this data normally distributed? So those assumptions can be verified by using this menu statistical tests. There are correlations. You can just find the correlation between communication and then reliability. First two questions of reliability, you see here, you'll find the Carl-Pearson coefficient. You have Spearman. That would be much better way of because this is ordinal data. We have to go for the Spearman row. And also Kendall-Stowe, Carl-Pearson covariance, something like that. You also have the regression. Suppose if you want to find if communication depends on maybe tangibility, so we can just perform regression just like this. See, this is our regression. Anyway, I'm not talking about the regression, theory of regression. This is just functionality of the. This is very much important for it. This is what is called patient analysis for the patient satisfaction. The real auditing starts with latent variable analysis. Now, if you look at this data, we have some certain factors. Say here. So the analysis is all about like which factor is important, which factor is not important, something like that. There are 10 factors in this data, and all these 10 factors can be fit against a particular. I mean, there are two components in this data, or constructs. One is service quality, and the second one is service. Patient behavior. You see, patient behavior were measured by using satisfaction. Okay, here there are three variables which represent satisfaction. There are three variables which represents the attitude of the patient. There are three variables which represents the perception of the patient. There are three variables that represents the learning styles of the patient. So now the assumption is, I assume that there are two constructs in this data. One is the patient behavior, the other one is the service quality attributes of the healthcare service, quality attributes of the healthcare service, and patient. So now we are just going to assume that there are two constructs, and which factor of the service quality influences the patient behavior. That is what is the question. Okay, we can just answer the question as which factor among this. There are 10 factors. So which factor is significant for a particular factor of the patient behavior? That is the question. So this tool answers that question. Now, if that is the question, you can just go to the EFA, which is supervised learning method. This is EFA. By default, I assume that there are two constructs in this data. Now we see there are all these service quality factors. These are two constructs, imaginary constructs. Suppose if we imagine that this is this hidden component or dimension is related to service quality, and this is related to patient behavior. Now it is easy to find out which variable fits well to service quality and which variable fits well to patient behavior. Now suppose if we look at the communication, it has positive loading but not very strong. We can just pick up one of the, we don't have none of the, actually this is a dummy variable. Doesn't matter, like when we come down to satisfaction, you have, here it is negatively. So obviously MR2 is not patient behavior, MR1 is patient behavior, MR2 is service quality. It has a lot of positive loadings from service factors and negative loadings from patient behavior. So this data might be useful for us to analyze what is happening in. Anyway, it will take a lot of time to pick each and every value and explain as what is happening inside this data. Now we can just go for a structure diagram, and If you select the structure diagram, there will be a diagram which is a visual representation to this numerical analysis. And then you have one kind of suppose if you don't know anything about this theory, and I just wanted to request what is happening in this data, and I don't know what are all qualitative factors and what are all behavioral factors. Now this will make your job little easier. You see here there are some factors, F1, F2, F3, something like that, and there is a general factor. Now if you look at F1, this F1 has few loadings from service quality factors and few loadings from behavioral factors. There is one positive loading from satisfaction, but most of the loadings are from the service factors. Now suppose if I pick up satisfaction, there are three variables here. Only one variable has positive loading and one loading has negative loading. And you see here there are few positive at moderate loadings from I think one of the service factors, which represents maybe, I don't know, this is communication and this must be competency. Yes, you see this hidden dimension can be explained with competencies and communication. And if we explain this factor positively through this communication and competencies, then we may not be able to explain the whole satisfaction. We will be able to explain only one variable from the satisfaction positively, but the rest of the variables goes now what are these variables? These are the questions. These are questions which we ask the patients to put their responses, that which range from 1 to 5, and F2 actually did not have any loadings, and F3, of course, there is another. These are the three different possibilities for dimensions, hidden dimensions. Now you see here this dimension explains accuracy, competencies, and security, and then also communication. And this explains perception but not satisfaction. So that way we can just analyze this data set. Suppose if you want to see the visualization, so this is one type of other visualization where we have three factors, the first and second factor. These are all red color arrows are significant, and black color arrows with some certain values or insignificant, something like that. Now there is another menu, CFA. This is actually the supervised learning. This is we'll be asking for just to fit two factors and tell me if my hypothesis is correct or not. Can I assume that this data just represents two invisible factors, dimensions inside this data? Now when we press CFA, we'll get some results. We have to wait for a couple of seconds because it is going to use some solver, unlike EFA here. This is more efficient method. Here we can just request some certain evidence in support of the fact that whatever we assume the number of. Now this is actually the default. You see the chi-square value is very huge, and we can just go and use this. We'll go for the CFA summary. Has much more detailed information. So you have AIC, BIC, and kind of A squared for these are all endogenous variables. CFA is a theory where you have exogenous, endogenous variables. These are all endogenous variables. Yeah, parameter summary. Here we can come up with each and every. We have three factors here. Only two factors. I'm sorry. We have two factors. Factor 1 and factor 2. You see here factor 1. Factor 1 with courtesy, factor 2 with security, factor 1 with security, factor 1 with these responses seems to be very, very important and potential. So earlier we just only analyzed each of these response against a dimension. Now we can look at what are all the important dimensions that are highly influential in this data. Now straight away we can go for the structure diagram, and here we can request for two solution. We imagine two different constructs inside this. So these are the two hidden dimensions, and these are the relationships with this service quality variables, and also there is again same omega plot which we have seen earlier. I think it is not coming right now here. I think that we can see here, I guess. See omega plot here, we'll see. This is omega plot. So there is actually, I'm not able to explain the total utility of this software. Perhaps maybe this is just a brief demonstration about this software application. I can provide much more detailed discussion utility. I can describe the total utility of this software application in detail through consultation. I mean, somebody can write to me or talk to me as how to make use of this. This is a very advanced tool, unlike iron triangle and Normality models. I also explained how to. I have another application to explain iron triangle and Normality models, which are also very, very important theories or models used in healthcare service quality. Okay, hopefully I explained in brief the whole utility of this software application in this video. If you like my video, please press like button and stay tuned for the new content. By the way, don't forget to write to my email ID in case if you need this software application. Thanks a lot for your patient listening.